Greetings everyone, welcome to question 3 of the level 3 2019 organic examination for level 3 chemistry. Let's get started. So this question, like expected, heavily based on condensation polymerization, because that's what I feel is probably the most difficult part in this particular standard. Well, it may be your weakest part in organic chemistry, but maybe after this video you should be your strongest, because it's quite straightforward. So let's get started. So nylon 66 is used to make airbags, blah blah blah. So this is the diamine, this is the dicarboxylic acid. So we want to draw a section of the nylon 66 polymer to show 2 repeating units. Now this is what I always tell people in my class. I will just go, all right, think of the year 12 monomers and making polymers. You're thinking about like you're the only one type of monomer, and then there are like a million of you lining up in one straight line, and then you decided to hold hands. That's additional polymerization. Condensation polymerization is kind of like you and your best friend, and then there are a million clones of you and your best friend, and then you decide, you open your arms out and you hold hands, and then you alternate. So you and your bestie, and it just goes on and forth. And then you react, you release something, and then during the process you combine together. Okay, so if you struggle with these, I tend to recommend people to do it like this at the beginning. Just draw them out first. I don't really care about what's in the middle. It's what's on the end that matters. Okay, so I'm running out of space a little bit, so I'll just be very conscious of my spacing. And then CH2 COOH. No, I'm not going to bother with that side because I can't fit anymore. So you need to realize that this is a condensation reaction, because the OH and the H, they are going to go and make water. So these things are no longer there because they want to make water. And during the process, you and your bestie start to hold hands, and then you join together. And that's a condensation polymerization. So the easiest way, so I'll just do it properly here. So we want 2 repeating units. So it goes like this. You can do, I'll make sure I space my thing better this time. CH26. A lot of condensation polymerization is to do with copying and pasting, if you want to do the hard way, of course, because I think a lot of you are struggling with this. So I'm just going to do the hard way first, then I'll show you the easier way. So if you don't like, as you can see, this is time consuming. Why did I decide to do the long way? But it doesn't matter, I'm running out of patience. Let's just do the side here. So you can see this H, this OH want to make water, and then you join together. This OH, this H join together, then you make water, and you connect everything together. So the end product is going to look something like this. CH26, so they want 2 repeating units. Oops, not NH2, it's NH1. Actually, I prefer, just to make it more clear, put the H up top. Actually, let's use a different color pen. Let's go with the light, let's go with green. Hopefully you can see this color. Oh man, that's an ugly green, but let's live with it. And H, so it's a lot of copy and pasting. Okay. So I just sometimes when I teach, I just tell my guys Control C, Control V, write it down, copy it, paste, then you're done. Okay, now this is where I will stop. I'll bracket, then I'll do an N. Okay, now this is how you can check if you've done this question properly. And you may go, but shouldn't that be NH2? Like, shouldn't this be NH? Shouldn't that be another H? Why did you bracket it here? This is why, guys. Let me just show you. You know how I told you before with the CON bond? You always cut here. You look for the CON bond, you cut here. You look for the CON bond, you cut here. And you should be able to see that this thing I just underlined and this thing I just underlined are exactly the same. And then these things that I underline with the blue and these things I underline with the blue are exactly the same thing. So if I put an H, like say if I put an H2 here, can you see that they are no longer the same if I put the H here? So I don't put it there. Okay, that's how we can check. But that's how essentially how condensation polymerization works. And to work backwards, let's say what if I give you this polymer here? I want you to work backwards. Cut it's even easier. Look for these bonds, cut, copy out the thing. Like say obviously these things are being repeated. Like say I'll just copy it. I'll just write it out like this. Just copy it, and I'll write this one out exactly the way they were drawn. And then I want you to think about how we can make this molecule complete, because right now this isn't complete. Okay, because this nitrogen doesn't have 3 bonds, this nitrogen doesn't have 3 bonds, and this is where you're gonna go, hold on a sec, condensation polymer. That means it lost an H. Hold on a sec, you can't just have C double bond O, that must be either an OH group or an Cl group. Okay, but that question probably come up a little bit later on hydrolysis, so let's move on. Why nylon 6s refers to condensation polymerization? That's because what is condensation polymerization is when you have small organic molecules or monomers, they join together during a condensation with a condensation reaction happening, you make a larger molecule. Okay, so you're making polymers because the small molecules join together to make a large molecule. And then they are being repeated, and that's what polymerization is. Okay, very straightforward. Move on. Triglyceride. So this is found in fats and oils. Below is an example. Put a circle around one of the ester groups. Easiest to achieve in my life. Done. Compare and contrast the acidic and basic hydrolysis of the, let's get rid of this because I need it later, of the hydrolysis of the acidic and basic hydrolysis of the triglyceride on the previous page. Explain what hydrolysis is and Okay, so first thing first, this is becoming a habit that I want, well, my habit, and this is a habit I want all of the year 13 chemists to have when you do condensation reactions. You look for the C, you look for that COO bond, draw a line, COO bond, cut it, and then can you see I can actually join this line together? This is triglyceride, so this is as difficult as it can get. Can you see that what's on the left hand side of the line? If I just copy paste, not tricking, copy pasting surely. I'll just copy paste everything that I've done. This is one molecule. This is 1, 2, 3 propane. This is propane 1, 2, 3 trial. On the right hand side, can you see the 3 things are exactly the same? Can you see that, and that are exactly the same? So that means I have, that means I have 3 of these. Okay, but then these molecules are incomplete. How do I complete it? Well, how did they join together in the first place? Doesn't make sense is that this H and this OH went off and then these guys hold hands. Shouldn't that have an H? Shouldn't that have an H? And this is what I meant by getting into the habit. You cleave it or you cut it, you break it, whatever verb you want to use. Look for the COO and the CON, cut it, and then copy, and then complete it. Don't, because I've had so many students memorizing, all right, I need to cut it, I need to cut it, I need to copy it, I need to copy it, and then they forget to complete it. If you don't complete it, then that's a wrong molecule. Okay, so what is hydrolysis? Hydrolysis is just using water to split. It's a reverse of polymerization. You using water to split the molecule into smaller molecules, and you can do that in acidic or basic conditions. So you need to heat them up. And in this case, if I do acid hydrolysis, you always make the same product initially, but when you think about the products you have made, you need to look at the condition, because this is neutral. This is neutral. That's not neutral. This is neutral. Why is that neutral? Why is the thing highlighted neutral? Because that's an alcohol. It's neutral. What is the functional group on the thing I just drawn? COOH. This is acidic. So in both reactions, you will make these two things initially. But if you do this in acidic reaction, nothing changes. You still make your alcohol, you still make your carboxylic acid. If you do this reaction in basic hydrolysis, your alcohol doesn't do anything, but then your acid, if you put carboxylic acid in basic condition, can you see that you're going to have a bit of neutralization reaction happening? Can you see that what do acids do when they react? Don't they lose the H? So you will make this. You will make the ion. You will make the carboxylic ion. So it's literally 1 letter difference. And that's the difference between a merit and excellence, my friends. So that's something you need to be very, very careful. So with this question, I feel it's easier. If you get a question on proteins where you have amino acids, again, I'm just doing a little bit more. If you're doing proteins, let's say if I so amino acid, I'm just gonna make up one really quick. Let's say if I make this, for example, if I have an amino acids like these joining together, if I do this in acidic reaction, so remember the COOH part is acidic, the NH2 part is basic. So if I do this reaction, like say if I have a protein, I break it, then I make amino acids like these. If I did the reaction in acidic reaction condition, my acid is not going to react. I'm going to make the same thing on the left hand side, but instead I'm going to make NH3 plus because the NH2 is basic. It gains another H plus from the acidic condition. You're going to make this. If you do this in basic condition, then your nitrogen doesn't do anything because it's already basic. But then on the other side, you are going to lose the H plus because it's an acid, because it is a basic condition. Okay, very important, very, very important concept. Can be extremely tricky if you don't know what you're doing, but if you understood this whole find the bond, cut it, copy, paste, complete, and then think about the condition, you will do really well in this particular section. Okay, this is very, very standard question. You know, I mentioned before, organic can be very unpredictable. This is the most predictable question. Okay, so good luck with this one if you have it this year. So here's NCEA, the mark schedule that we got. The products, so like always, you can see the alcohol doesn't change. They draw like this, so you can just do what I did. But the difference between the acidic and basic hydrolysis is the H and that minus, okay, because of neutralization reaction. So just remember hydrolysis, you split large molecule into smaller molecule. You can do this in acidic or basic conditions. You have reflux, that means just heating it. Keep everything in the solution, heat. It's kind of like a pressure cooker if you think about it in a way. Now and then you make the alcohol and the glycerol, the glycerol and the carboxylic acid, and then acidic condition, nothing happens. Basic condition, the acid gets neutralized. All right, last question for this particular exam. Now this particular question is becoming a bit of a trend. This happened in 2018 as well. They want you to write a reaction scheme to convert butanol into butane 2,3-diol. So first of all, you have to be able to draw them. So what's butanol? This is butanol. What is butane 2,3-diol? This is butane 2,3-diol. Okay, so they want you, actually, get rid of this. Let's put it way down here because I may need all the space. And you're like, how the heck am I gonna get that? So they're saying, I want this last. So we're gonna do this in 4 steps, okay? But how do we do this? The best way with the flowchart questions is that to tackle these questions is that you can't keep going from top to bottom. Sometimes you have to work backwards. If I told you, I mean, how the heck do you get C double bond O? don't you get this from COH and then you just oxidize it? Okay, so you just oxidation, you just oxidize this reaction. So technically, shouldn't I just have for number 3? Shouldn't I have that? This probably takes more than, I think I don't want to number these. I probably need a few more things. Instead of 1, 2, 3, 4. But this is our end product. Like, doesn't that make sense? I want the C double bond O. How do I get the C double bond O? Oxidize the alcohol. So this is oxidation. So I can just use lys. Let's yes, this is the right one. I can just use MnO4 minus, or what do you call it? You can use MnO4 minus or Cr2O72 minus. Okay. Now the next bit that you can do is this. You want to turn the how do I get from here to here? Well, this is a diol, isn't it? How do we turn something into a diol? An alkene. Year 12. Okay, so you break the double bond. Again, how do we do this? This is oxidation reaction, and you will need to do this in MnO4 minus, and you need to do this in neutral condition. Something you need to realize that neutral, if you do a lot of the oxidation reactions you guys learn in redox internal, most of it is acidic. Alkaline conditions also helps, neutral conditions also helps. So you do this in MnO4 minus. If you forget neutral, it's not a big deal. MnO4 minus is a key ingredient. Don't put Cr2O72 Cr2O72 minus here, because that will be an incorrect structure. MnO4 minus is the one to go. So that's again oxidation. Oops, oxidation. This is oxidation. Okay. How do we get that butanone to something close enough to an to a ketone? Well, can't I make that into an alcohol? How do I do that? You use sodium borohydride NaBH4. So you do the reduction reaction. You turn the ketone into the alcohol, and then you have the alcohol. Oh, look at that, turning an alcohol into a CC double bond. What was that again? KOH alk. So how many steps is that? That's 1, 2, 3, 4 steps to get to the end. Okay, so that's a bit messy. Let's just because that's the last question, let's just make it a little bit neater. Let's just go down, let's just go all the way down. All right, let's start again. Let's make this super neat. So first one, we want to have we are starting with butane 2-on, and we want to finish at butane. I mean, you can look at the answers at the on the marking schedule, which is easily accessible on the NCEA website. So I need to use a diol to make this happen, which is you can use Cr2O72 minus or MnO4 minus, doesn't matter. Then how do I make a diol? I use this. I didn't put H's. Make sure you put H's. Sorry, I'm just being a little bit lazy here. This is when you use MnO4 minus. And then how do I make the alkene? You use this. You use the alcohol, and then you use the sodium borohydride. So this is year 13 reaction. How do we do this? This is KOH alk. This is year 12. This is year 12. This is year 12/13. 13. Year 13, ketones year 13. So this is a combination. I mean, they didn't ask you to explain what type of reaction, but if they did, this is reduction, this is elimination, this is oxidation, this is oxidation. Okay, so hopefully this is helpful. This video has the series of video has been helpful to you. Like always, leave a like, subscribe, help the channel grow so more students like yourself can benefit from these videos. And I mean, the end goal is that you get better results in the end of the exams, get better credits, and leave more doors open to you when you can choose what career pathway you want to follow. Okay, so like always, study hard, stay safe, and I'll see you guys next time. Bye bye.